Hello and welcome. This is another one of the RunDiffusion interview series. My name is Revolved, and I'm here today interviewing our fantastic community member, WarAnakin. Hello, hello, welcome.
Hey man,
And WarAnakin, just recently you won the Civitai Model Training Contest, which is a huge accomplishment.
that's true. It was completely unexpected. When SDXL got released, just like everyone did, we kind of wanted to jump on the wagon, and be right there when SDXL is out 2 weeks later and have a model ready. So basically, that was our game plan. We didn't do it to, uh, be in a contest or anything. I don't know, it just happened, man. We went with the flow. The contest was there. It just happened that we uploaded the model. I didn't keep track of what's going on. I was busy because with Crystal Clear, there's a lot of stuff to do. Even though we don't release models often, on Civitai, we do have a lot of commissions to tackle, so there's a lot of stuff going on. But I believe it was a Friday night that someone from the team, I think it was Joey, he said, "Congratulations, Team Crystal Clear." I'm like, "On what?" He's like, "You guys won the Civitai Model Contest." So imagine my surprise on it, But it's a blessing, the fact that. We were able to get first prize, which was a 4090. I actually got the card and it's running inside the computer. I'm pretty happy about it. Before this, I was running on a GTX 560 from 2012. It was 11 years old, man. But kudos to Nvidia for video card reliability, because 11 years, and it's not even a high-end video card, it was like a medium range back then, a 560. It still kept on kicking.
You mentioned, we, and I'm guessing you're talking about the Crystal Clear team, right? Because you have a Discord, you have like beta testers. You want to talk a little bit about the team and how you guys work together?
Sure. So everything started mid-March. I was aware of Stable Diffusion, since last year. With 1.4 being released and seeing how you're able to basically generate images from text, and I was seeing people use Invoke AI to basically when you get part of a picture and then you in-paint additional stuff in the same style that the original picture is, so that thing kind of, swiped me off my legs, and I was pretty impressed. Mid-March, things started calming down. I wasn't as busy, in real life anymore. So I thought it's a great opportunity to jump on this while it's fresh. I really wanted to be there and grow with this thing. So in order to do things properly, I told myself I can't do this alone, and we know as people that we work better as a team. Teamwork does the dream work, as the per saying goes. So I decided to look for people that are talented in this field and start a team with them. And that's how we started Crystal Clear. Of course, the first model that I developed, I've done it alone, but that provided enough traction for me to, reach out to talented people, and it was a team effort. Everything that we do is still a team effort, but Crystal Clear Excel, since we were talking about it for winning the contest, it was a team
Yeah,
effort.
and I think the quality of the model speaks for itself. That you kind of have the right direction that you're going for creating these models. There's a reason why I won the contest, right? And part of that is the really flexibility and like how you've trained it to respond to all kinds of different prompts in a great way. Um, did the team like was having a larger team what sort of helped you do that? Like that the multi-purpose model, is that what helped you get that great coverage and training on the model?
There's not. that many people. We're about 15 people. A big part of being in the Crystal Clear team is that I'm looking for people that are active. So it's not like, oh, you come once a month, you do something, and then that's it. No, these are active people that are involved in everything that we're doing. So with Crystal Clear Excel, we actually had a discussion in the beginning. We were thinking, okay, what avenue should we go on? Should this be a photorealistic model? Should it be a more animation inclined model? And as feedback and testing progressed, we're like, okay, well, everyone is doing photorealistic or it's aiming for something particular in this direction. So why not just make something general that can, satisfy a large number of people, whatever their artistic inclination may be it photorealism or they want to be involved with artistic stuff. That's why Crystal Clear is what it is. It's by default, people called it the stylized model, and it is true. In order to, satisfy all these particular styles that are that the model can provide, well, it needs to be stylized. You can't have a model that's photorealistic by default and expect it to do animation. It's like, okay, we have a photorealistic model. Let me prompt, I don't know, Hulk Hogan and expect him to look like a cartoon, without inputting in the prompt things such as cartoon or
Yeah,
things like
yeah,
that.
that makes a lot of sense. So this is something where SDXL sort of really shines, right? Because its model, it's so much more vast than 1.5. You got so many more different styles and illustrations and so on loaded into it. How was training SDXL different than training 1.5?
Well, first of all, it's the quality, and second of all is the hardware. So they kind of go hand in hand because in order to have good quality, you need to spend more resources. So on my end, seeing that I did not have a proper computer to do this locally, I relied on cloud, and having the team also helped out, because everything that we've done, for example, in terms of testing, let's say, and by the way testing goes inside Team Crystal Clear is not like there's a guideline for 5 people to follow that guideline and then at the end come back with the same result 5 times because that is pointless. Everyone, as I've told people, everyone is unique in their way and everyone has different hobbies and is creative, in a different style. For example, you might like stuff that it's CGI. I might like stuff that's pencil sketch. So having the members generate images in their own particular vision is a great way to cover, wide range of image generations. Talking about that, you know, without having the team, it wouldn't have been possible. To come back to the fact that everything was run in the cloud, services such as RunDiffusion provides, they were critical. And the fact that we have this relationship and collaboration, I mean, on the side of Team Crystal Clear, RunDiffusion has been very helpful in moving forward, with our model generations, as well as some of the commissions that we're doing. So, for example, we have team members that they run on the, excuse the expression, shittier hardware. So having the possibility to run the test in the cloud was of great value, especially seeing how SDXL is more resource intensive and the fact that the images they're 1024 by 1024 by default. Training, takes a lot more power. And same goes with, generating test images because you're not generating 512 by 512. You have to up it up a notch.
Full disclosure, Team Crystal Clear is on the RunDiffusion team plan. You've got the shared storage, so kind of everyone's beta testing of the models kind of goes to the same place. It's easy to share. Yeah, I think you've really shown what's possible with a larger team, and it is a unique way of approaching this because The way that we use stable diffusion models is changing. There's such a wide variety of use cases for it. SDXL has really opened up a lot of different use cases. So there's a lot of testing that needs to be done. Let's talk about a little bit about your process for training the model. I'm sure there's lots of people who are curious. Since you won the contest, how did you go about it? Maybe just start with you mentioned you trained in the cloud. What platform were you using to train the award-winning model?
I was running everything on Google Colab. So in order to train, and what I mean by everything is that I was training everything on Google Colab, which has been pretty useful because um, we have a team storage, and it's been very easy to move files amongst the members. And also, RunDiffusion has the GDown integrated in their services, so moving stuff from one side to the other was very quick. But to be honest with you, to train Crystal Clear Excel, we used Kohya, but a modified version of Kohya because it was always throwing a text encoder error. SDXL has two text encoders compared to one on SD 1.5. So we had to modify the source code of Kohya in order to be able to train crystal clear Excel. We didn't make any changes related to the quality of how Kohya trains per se. It was purely related to the way the system accesses the second text encoder and trains the model.
Yeah, the nature of this AI application is it's changing all the time. There's new stuff, bugs get fixed. I know that the bug that you encountered is fixed in Koya. Lots of people are using Koya now, but at the time, that shows a lot of ingenuity to get it fixed for the contest. And since that contest, I think a lot of new tools have popped up. You've got Every Dream and One Trainer, and yeah.
We put a lot of heart, dedication, passion, and we didn't give up. We found the issue, we asked for help, we couldn't find the help we needed, so we took the matter into our own hands. Because the team is not just made of people that generate images. We have developers, we've got people, artists, they're incredible at drawing. We have people that are specialized in prompt generations. There's a lot of variety among the members.
So to start off with Crystal Clear XL, how many images were used to train it?
There were about 1100 images in total, but it's very hard to give an exact number due to the fact that the way crystal clear models are trained is just different than how the other creators are doing it from what I've seen and what I know so far. The way the model is trained, basically there are all these smaller packages that impact particular instances on a global scale inside the model. So let's say you have things that relate to lighting or to the sharpness of the model or the blur or exposure, colors, things like this. I could keep going, but so far there's about 9 individual packages that I'm using in order to train models. So the way this goes is I train myself a base with the images that I have, but don't forget these little packages, these checkpoints or LoRa's, because I have both that I'm using. They're also trained themselves on images, like they have their own data set as well, like I said, because it needs to impact, specific, aspect of the model. So let's take colors, for example, because colors, it's easy, it has to do with vibrancy. Let's say you have something that's very green inclined. You have a model that, I don't know, just produces green, extremely, or it's very blurry. At that point, you're gonna use a sharpness package or a color related package in order to tone down that specific aspect of the model. That's why if you're looking at the list of features for Crystal Clear Excel, You're gonna see things like global illumination and stuff like this. I know that some people might think like this is BS or it's not possible to do with the model, but I believe we spoke in the past about something called emergent AI properties, where you're doing something and the system itself is kind of learning and adapting, as it goes without it being the actual intent of the developers in the beginning. Doing things like this on a global scale, being able, to tone down the colors and other aspects like, let's say, sharpness, as I've, mentioned, gives you a greater control over how the model looks. That's how training goes for crystal clear Excel. So when I give you 1100 images as base, yes, there are 1100 images, but taking in consideration all these other packages that are being applied, it's very hard, to give an exact number of what the result, has been trained on.
Okay, okay. I'm going to break that down a little bit because there's a few things you touched on that are pretty interesting there. For the emergent properties bit, I I think you're referring to the like that research paper that was published where stable they found stable diffusion had sort of a 3D perspective on the images it was making that was not trained into the models, right? It sort of like created this emergent 3D layer of understanding of the image. Is that kind of what you're talking about with
Yes,
emergent
you are
properties?
you are right. You are right.
Yeah, yeah. I mean, it's incredible tech to see that kind of stuff, and I can only imagine as we add in like multimodal models that can do vision as well, like ChatGPT did. We're gonna see some really impressive emergent properties. And so you're talking about these packages where you have like lighting and color and clarity and sharpness. You're training these separately into checkpoints, right? So you kind of have like a color checkpoint, a sharpness checkpoint, and then are you like merging these together? Like how are you putting these together into one base model?
That's how it goes. It's with the merging process. So when you're merging, you actually have the scale. So you can either addition or subtract from a model. Now, the catch with subtracting is that you need to put your result somewhere. With addition, it's simple. You just do 1 plus 1 equals 2. But with subtraction, you need your result to go in another model. So it's like you have 2 minus 1, but then you need to put that 1 somewhere. So usually it's either an empty checkpoint or is crystal clear related. Let's take it 2 steps back when the image, I'm not the image, the lighting was not as strong as it is now. Probably training the model on some particular images, kind of overshot the lighting. So at that point, what I do, okay, I come back 2 steps and, I use these packages to tone it down a little bit.
Okay, okay. That's interesting what you said about subtracting too. So you're not only creating these sort of positive packages, but you're also saying like, hey, I'm going to do some negative, like maybe some bad data. Like let's say a common example is like eyes. Like some bad eye data came in and the eyes were coming out wrong. You would sort of like subtract that and then replace it with like another token or another set of trained data. Is that right?
It's the particular data itself. So let's say we have a checkpoint that has, I don't know, a red car, okay? And I also have a LoRa of that particular red car. So at this point, what I can do is I can subtract the red car from the checkpoint that contains it and put the result either in an empty shell of a model or in whatever it is that I'm trying to, work with. So basically, that's how it goes.
Okay. Interesting. So that makes sense. You're looking at it from a data perspective, sort of carving it like a sculptor would carve a statue.
Pretty much, but in case of these packages that I'm mentioning, seeing that you can't really compare lighting to a car or sharpness to a car, in that sense, that particular slider is being used as a strength. How much do I want to apply to the model or how much I want to subtract from the model.
Oh, and that's where the advantage of merging comes in because you're able to sort of like mix these like a mad scientist in a lab, right? Like, you're putting in, oh, I'm going to merge in, 0.3 of this lighting type and 2.1 of this color type and so
Yeah,
forth.
it can drive you crazy.
I bet. But that's impressive because, this way is really intelligent. You're able to train all these packages and then piece together the ultimate model, and you won't have to do so many cycles of actually spending the money on the hardware to train it or training it locally. Instead, you're kind of breaking it down bit by bit into the component parts of the end result that you want, and then you're able to mix and match those components to get the desired result. And what I've seen with merging is that it can be really, really valuable to get like that additional flexibility in the model. And from what I understand, crystal clear, like you didn't merge any other models in. It's not a model merge, but it is something where you've trained all these different pieces and then merged them together. Is that right?
It's right, but you do have the base, like the base stable diffusion model is always gonna be there. So this is not something that's trained from
Of
zero, you
course,
know.
of course. Yeah, that would take a lot more GPU cycles than you or I have access to at the moment. So I understand. How did you go about captioning this data set? Was there anything specific that you used? Any methods? Did you do it manually? Did you automate it? How did the captioning go for you and your team?
Well, we prefer to do it manually. Most of the time is because of the commissions that we're dealing with. So usually for commissions, the clients they have specific requests. And let's take clothing and apparel, for example. Let's say someone comes to you with red hoodie that's sitting on, I don't know, a person. At that point, you want to describe the hoodie as much as you can and want. You say, okay, it's made out of wool or cotton. This is the L size or the medium size. You need to put all these little things in a model that's, for example, related to clothing and apparel, because these people they're gonna put it in a catalog, and they want to make sure that, okay, this is the L and this is what it looks like. This is an S size hoodie. This is red in color. This is orange. This has plate patterns. This one has engravings on it. And the reason for this is, believe it or not, the clothing and apparel industry is one of the most demanding commissions and things that you can work on, because the end product needs to match 100% the source product. Otherwise, you're gonna put into catalog something that doesn't match the item, and you're gonna ship it to the customer, and you're gonna get maybe a crazy Karen. Is gonna be like, well, this doesn't look like what I ordered. In the catalog, it looks like this, but I got it like this. And at that point, who's gonna be, to blame? Is it client because they trusted us, on providing something that's 100%? Is it us because we didn't train it proper enough? You see where I'm going with this. So it's a pretty demanding, place to be.
Yeah, what you said about the difficulties in doing like in particular fashion or apparel is interesting. I'm just impressed that you do manual captioning. I mean, 1100 images manually captioned is no joke, and that's not even mentioning all the different packages that you did. So that's pretty impressive.
Well, of course, we are using for example, the Deboru tagger, the software. Yeah, that's coming in handy, but it's still like a manual process because we still have to select the images. We still have to say, okay, this is a sweater. We prefer doing these things ourselves rather than leaving the system to do it. I mean, how is the system going to be able to differentiate between cotton and polyester? You know what I mean?
Oh, that makes tons of sense. So it's kind of like augmented captioning, where you're doing like a lot of it up front. You say you use the deep buru, and then I mean, with deep buru too, I know when you use it, you'll get like anime character names in there and stuff like that, right? So you have to kind of clean that up.
Well, we start from scratch. So when we open our Deboru, we load the folder, there's nothing. Like it's empty. And that's how we start. So basically, we choose all the things that are similar in nature. For example, let's say this is a picture of a sweater from the front. So we're gonna select all the instances of the sweater that are from the front, and we're gonna caption like that. Like we're not gonna go one image one by one. We did that in the beginning and it's just a pain. Imagine if you would have to do it for 2,000 images. And to give you an example, we had a commissions just quite recently about a model that's able to generate logos, 9 particular styles of logos, and it came out to 2,000 images. Now, imagine captioning 2,000 images where you have to specify for each one of them, okay, this is a white outline logo, this one has thin fonts. This one is sans serif. This one is serif. You would go crazy, man. Like I don't have hair on my head because I'm bald, but I would probably lose another, layer of hair.
I think we're getting to the point where there will be better tools for it. But you're right. You could go as deep as you can imagine, right? And you could go very, very deep and caption every single object on the screen. You could capture every single style and just spend unlimited time captioning. So it makes sense to get like just the vast majority of what you need done. I'm curious, you're talking about commissions and stuff like that. So it sounds like, you've been able to sort of make commercial success as a model trainer. I'm sure the Civitai contest helps with that. How do you see kind of the state of the industry for model training right now? I know this is a rather vague statement, but where do you kind of see it today and where do you see it going?
For sure, we're gonna have this professional avenue that Stable Diffusion is gonna go down on. So, for example, when it comes down to architecture-related content, I'm pretty sure there's gonna be architects out there that will want to present to their potential customers specific style, of architecture or a house that's, I don't know, modern or futuristic or things like that. I'm not an expert in architectures and styles, but just to give you an idea of how stable diffusion can be used, for example, in these, high-level meetings for real estate, man. That's the word I was looking for, yeah. But this is just an example for real estate related content. Now, you could do it, for example, for toothpaste. Let's take Colgate or I don't know, Blendermed. We could take toothbrushes and things like this. So you wouldn't need to go through the complex process of creating a commercial, where everything needs to be accurate and you need this particular type of lighting. You won't need all that because once you train this in the system once, is enough for the system to know, how to generate images going forward. At which point it's going to be up to you if you want to change the background lighting to red or leave it to white. It's going to give you that flexibility where in real life you would have to go through these notorious processes, and not to mention it will cost money every single change that you're gonna do, whereas on stable diffusion you pay it once and that's it, you have it for life basically.
What kind of challenges have you faced? I mean, I'm sure not everyone understands model training. They might just be like, "Oh, I've used Midjourney before." But what kind of difficulties have you faced as a model trainer that's working to make money training their models?
Well, when it comes down, like I said, with clothing and apparel industry, if someone comes to you and they say, okay, I want 100% likeness, imagine having a person that has, 100 tattoos over their bodies, and they're gonna ask you to reproduce, their entire body 100%. So accuracy is going to be pretty difficult to achieve, especially if you want to keep the consistency. Because right now, when you generate an image, let's say of a man from a distance, he looks like this, but then when you move to portrait, all of a sudden he's got green eyes and red hair, and just an image ago he was blonde. So accuracy is one of the biggest things. And then another one is it has to do with captions because if the client doesn't understand how the system works, then when they're gonna try to generate their images, they're gonna be like, well, this is nothing like what I expected. So communication and bringing everyone up to speed on what Stable Diffusion is able of doing and what the limitations are is going to, impact this a lot going forward. Like it is a challenge, but compared to 100% accuracy, this is something that can be remediated through a talk, or you could take a course, on Stable Diffusion.
It's a really interesting balance in model training in particular with accuracy because you can get better accuracy by training longer, but then you lose some of that flexibility because you've overtrained. So, an example would be, let's say you had, my example is like I had 15 images of a person to train. But then if you overtrain, yes, you will get better reproduction of the face and it will look better. But then those 15 poses are all you kind of get. You don't get the ability for it to create new poses or to have different like perspectives because of the overtraining. So it's sort of an interesting balance with accuracy. In the current ecosystem, I think this is definitely something that's going to get better over time, right?
Give you a little bit of insight on, on training. There's all these different types of training optimizers that you can use. There's Adam 8-bit, which is kind of sketchy on Excel. A big one that the community is using is Ada Factor. You can also try the SG Nesterov, not the 8-bit version, the regular version. There's also Lion. There's Prodigy as well. There's quite a number of them. Depending on what it is that you're trying to achieve or train on, choosing the right optimizer can impact the results of of your model. And to push it a step further, for example, even after you choose this optimizer, you have the scheduler, such as cosine or polynomial or constant with warm up. Now, all these are also affecting, the speed at which the model is running and the, accuracy of your result. For example, if you choose polynomial over the others, training for as long as I have, I've come to realize that polynomial out of all the others is the one that is best at avoiding, for example, clothes clipping through each other or things that are really look really mutated in nature, such as an arm going through the body or things like this. It kind of has to do with the actual algorithm behind polynomial for the resulting images. I use cosine a lot as well. Cosine, especially in Excel, is pretty good at producing, five-finger hands. But even for that, it depends a lot on your data set. So, for example, you have people that are trying to produce model or train a model that is going to give proper looking hands, but then in their data set all they have is like people that always are showing the five fingers. In order to properly train a model, considering the fact that in your generation doesn't mean that your model the resulting image is always going to be of someone that's basically going to show you their hands. Sometimes they have their hands on their hips, well, other times they hold them above their head. So it's important for the model to kind of get this 3D image of what a hand would look like, which kind of brings us back to what you were saying previously about the emergent 3D nature of the model.
It's interesting all the different like algorithms that are out there. There's so many, and they all have different learning rates that work well with them. It's a very tricky like space to navigate, especially if you like no machine learning background. I don't know a lot of what those mathematical algorithms are based on. But at the same time, the samplers that Stable Diffusion uses, like Euler or DPM, we use those. We don't really understand the math that goes behind them unless you are a machine learning expert. I'm really glad that there are like easy to use tools that have been popping up. Dreamlook is a good example, or like the Civitai trainer that they're beta testing right now. Very easy to use solutions to get into model training. But I do think like what you're talking about, that kind of thing is necessary to make a very effective model, one that wins contests or can be sold commercially because of kind of those challenges that you're talking about with accuracy and so on. You really need to dive deep into the guts of the thing and really figure out what is the best way to do it. It really helps to have a team of people testing it, of course, as well as you have. Yeah, that's worked out really well. Um, so yeah, this has been a really fascinating conversation. I'm really glad we got some time to kind of go over this and learn a bit more about what made Crystal Clear an award-winning model. Um, yeah, so thanks for your time and for walking us through that. I really appreciate it, WarAnakin.
No problem. Thanks a lot, Wolf. And like I said, man, this wouldn't have been possible without, getting the proper backing that RunDiffusion was able to provide us, through our adventure.
That's really great to hear. So how can people support the next venture? Where can they go to learn more about Crystal Clear and the team that you have?
Well, we do have everything that we do so far is on Discord. So we do have a Discord server that I'll be able to provide you so you could put it out there. Also, when they go on Civitai, the model, there's a link to our Discord server as well. So, they're able to find us from there. Like I said, so far, Civitai is the place where we release the public models, but we are just extremely busy. So the audience we're having is not just Civitai, but you can't see it, but it's out there. Like so far, we've done commissions for automakers, game developers, logos. Also, we have commission to work with Instagram influencers, people. So clothing and apparel, man, there's quite a lot of them if I start thinking about it. But yes, usually so far it's been word of mouth. That's how news has been spreading about Crystal Clear.
That's awesome. Well, I'm so happy to hear about your success. Congratulations again on the contest, and yeah, we'll be watching to see what comes out of the Crystal Clear team next. We've got links in the description for award-winning model Crystal Clear, as well as the Crystal Clear Discord. So yeah, thanks everyone for tuning in, and we'll be back with more interviews. Thanks for your time today, WarAnakin.
Thank you.
Bye.
Bye.